Welcome to Energy Innovations, a regular video series that explores the latest innovations in technology, digital, regulations, products, services, finance, and business models that are impacting the energy sector. Energy Innovations interviews entrepreneurs, energy companies, capital markets, and regulators to understand how the energy industry is changing.
Welcome back to Energy Innovations, and today we're going to dig into a fast-moving but critically important field related to data collection, and specifically the development of digital twins of terrestrial infrastructure. And a pioneer in this whole area is Joseph Hlady, who is the president and co-founder of a company called Lux Modus, which is based in Calgary. And Joseph, welcome to Energy Innovations today.
Good morning, Jeff. Thanks for the invite. It's good to see you again.
Good to see you too. We actually go quite a ways back before we came on air. We were sort of speculating about when we actually met, but it would be literally almost 20 years ago when I was also working in cadastral mapping and surface mapping capabilities. And even back then, this was an area of passion for you. I wonder if you might just sort of share a little bit about your personal background.
Sure. So my background is in 3D mapping. I'm a geographer by trade. I was in academia before, but spent my entire academic time and all of my career in using LIDAR for mapping infrastructure, mapping terrain, and applying it to large geographic areas. For the longest time, laser scanning and 3D mapping. In the early days, like 20 years ago, Jeff, when we first met, it was really focused around airborne collection of large geographic areas, and had limited application. And I've had the benefit of working with many companies that helped us, me and others, bring 3D mapping to the ground level, high density, and mapping in great detail as opposed to the general mapping large geographic areas. So I've been doing that for 20 years on capital projects around the world, rail lines, power lines, pipelines, as well as for urban infrastructure and the human side of mapping as well.
Well, let's unpack this a little bit. I mean, why is terrestrial data collection at the granularity and scale that you're currently working on? Why is this important to do, and why is it hard to do?
Well, it's interesting because for the longest time, literally for several thousand years, either you had no information at all, or you sent out a surveyor. And surveying manually with people is slow and tedious and can be hazardous. And a surveyor can only collect so much information in a day, and they can only really collect information and data on things that they can see, or that they can look through their instruments and actually look at, do measurements, or stand there and take measurements. So the level of granularity for manual survey that we can provide is hard. And so there's always been this kind of ceiling of how much detail you can actually get. And again, because it's a manual task, you could only do so much so fast. And for the longest time, that was good enough. But now projects are more and more expensive to do. People want more information in more real time, and constructors and operators have learned to realize the value of having detailed information as regular as possible. Can improve construction, improve asset construction quality, and the life cycle management of assets through time. So being able to collect really detailed data very quickly and very inexpensively and at scale there's been demand for quite some time. But only in the last kind of 5 or 10 years has really the technology got to the point where it could be done quickly and inexpensively. And as you mentioned, it's very hard to do. The technology is very, very complicated. But thanks to advancements in the autonomous vehicle mapping industry, as well as, frankly, in the defense industry, a whole bunch of technologies come to bear that's very inexpensive and relatively easy to integrate. And that's what Lux Modus does. So we've been able to take borrow technologies from the autonomous vehicle industry
and kind of mash them together,
and mash them together, and now apply them to the business problems that we see in asset construction and asset lifecycle management.
Now, those of us who wander around the planet, and I think that would be everybody on 2 feet, we will regularly see two chaps with a yellow tripod and magnifying lens, like a telescope, and they'll often have these days a little white dish mounted on top. So they're surveyors. And but they're not collecting anything close to the kind of data that you're talking about. What is the if you don't mind, just describe the technology for me and how it actually hangs together that allows you to collect these data sets of information about the terrestrial landscape around us.
Certainly, you're absolutely correct. And the surveyors that are out there, they could be doing different types of survey. Particularly, they could be doing a legal survey, so they're taking points. Very high resolution, millimeter accuracy to distinguish property boundaries, to distinguish the distances between objects such as building facades and so forth, or the height of a curb. But when they do that, as you mentioned, they have a GPS antenna, that little white puck on the top of their tripod, and they're collecting points, and then they connect all those dots and make a line to say that's the curb or that's your property line. And that's great for legal survey, but when you're trying to model like a building or the pipe buried in a ditch over hundreds, if not thousands of kilometers, that's a very tedious task. And so what our technology does is basically it has 3 components. And again, a lot of this is borrowed from the defense industry and the autonomous vehicle industry, but we have a laser scanner. So you've heard of various LIDAR companies. We are partnered with one of the leading LIDAR companies in the world called Ouster out of Silicon Valley. They're the world's leading digital LIDAR company. And we have a laser scanner on the front of our equipment that emits 1.3 million points per second in a revolving fashion. So it kind of scans the terrain. As you move along, it's kind of painting the terrain with laser points. And then we have what's called an IMU, or an inertial measuring unit. And what that does is it records the trajectory or the platform through space and time. So when the laser is shooting out a point, and it's hitting a target like a wall, it actually knows where it is from 1 millisecond to the next. So it can actually produce, it fills in those points to fill in space, time. And then we have GPS antennas, very high precision GPS antennas that give us extremely high time recording and positional recording. And integrating those 3 components together, we're able to build a 3D point cloud, or a 3D model of billions and billions of points of an object. Or whether it's a pipeline or a rail line or something like that, and it basically produces this detailed 3D model. So instead of having a few points like along a sidewalk, like if we're measuring the top of the city wants to know where the top of the curb is for a certain, instead of having 2 or 3 or 4 points, survey points along that, we'll literally have 50 million points. So it's an enormous amount of detail, and it sounds like it's many orders of magnitude more data in terms of points, but it's actually less expensive to do that than to go out manually and collect those points.
And that's because the technology for doing the measurement is the individual measurement is basically free, because you're sending out a laser ping to detect an object and record its actual location. So it's effectively free. I have to say, unless I didn't know any better, this sounds like it could be large, bulky, power intense, hard to manipulate around, et cetera, et cetera. I'm going to guess that that's not true, that this is probably a lot smaller now, because everything's gotten smaller, and you can buy camera technology now, but it's basically built into phones. So tell me about the size of this. So what does this actually look like in its power consumption, its physical dimensions?
Certainly. Well, start off with you weren't wrong. You're correct, conventionally speaking, and that's why we built Lux Modus. Traditional mobile mapping or terrestrial laser scanning, the market has been filled with our competitors or other companies that produce very large, very expensive, very complicated pieces of equipment or mobile mapping platforms that are very hard to use. You require special training and so forth, and they are very power intensive. They're very heavy. They can only be mounted on a vehicle a certain way. And we found all of those parameters restricted the use or created barriers to entry for other people, for most people to use 3D mapping technology. So there is an entire area of infrastructure mapping and maintenance that we believe was underserved because of these barriers to entry. So to prove you wrong, Jeff, we created a system that isn't like that at all. Yeah, it's extremely light. It's about the size of a shoebox. It only weighs 12 pounds, 14 pounds if you include the power cable and the umbilical cord. The next closest competitor weighs close to 100 pounds. So ours is very small, uses very little power, and is extremely easy to use. It doesn't even have an on and off button. Once it's powered up and you have a laptop or a tablet, you can control it with. You tell it to start and stop recording. It can also be set up to just record data all the time and then use machine learning to figure out what data it needs to keep and which data it needs to delete or that you don't need. And it just records data all the time. So we have a device now about the size of a shoebox that a single person can set up and mount, and it can be configured on vehicles, whether it's a bicycle or a pickup truck or a golf cart, and it can be mounted on any of those kinds of platforms and driven around. It can even be pushed around on a cart or even carried around if you want. You only need one person to kind of do that. So it's we're really breaking down a lot of barriers to entry and making 3D mapping affordable and accessible to pretty much anybody that wants to use it.
And if you mount it on a, I assume it works better if it's at a higher, higher up off the ground. I mean, because you can't see what's on top of a roof if you are below the roof line. How high off the ground do you have to get before you can collect really meaningful terrestrial data?
So it depends on what you're collecting data for. It's a very good question, and it's a little bit of a complicated question, but we believe we produced a simple solution for it. Mm-hmm. So all the other traditional mobile mapping systems that are out there, the expensive ones that I mentioned, they just collect data in all directions all the time, mounted on the roof of the truck and only mounted that way. Our system has what's called an omnidirectional, what we call the omnidirectional mounting system. So our system is designed, it also has 3 ultra high resolution cameras that are orientated a certain way. Our device can be
visual like cameras.
Yep. Cameras, but they're ultra high res. They're 13 megapixel cameras. And they're synchronous, and they record just like the LIDAR does. So we can colorize a point cloud, but you can also just have geo-referenced photos as panels that you can look at. So you want to look at that stop sign, you can see that stop sign. You want to see that weld on the pipe, between the 2 pipe joints, you can zoom in and even see the crown of the weld in our photos.
Really? So that quality of resolution. So I'm trying to imagine now, I put this on a utility vehicle, something light, safe, but I'm driving the construction site, and the whole time the LIDAR and camera devices are building a data version of this physical world right down to where the welds are located, including condition of the weld. Yeah. Precisely.
So that's exactly right. So back to my point of, depending on what you want to capture, you mount it in different ways. So the LIDAR system has a range of about 3 meters, where about the first 30 centimeters, the data is not very good. It has a minimum range, but beyond 30 centimeters, we can go out as far as 100 meters. And so depending on what you're collecting, if you're collecting for a pipeline, you would point it off to the side and you're looking at the pipe in a ditch. We have an application for what's called curb management of, how much curb space is being used for parking, and what are the parking restrictions. Our city's maximizing the use of the curbs they have for revenue generation. You turn it on its back and have it look up, because you're not interested in the asphalt, you're interested in the curbs and the stop signs or the parking signs, and you mount it really low to the ground, like off your trailer hitch receiver, and it's collecting that. In the case of power line collection, if we're doing vegetation management or just corridor monitoring for power lines, you mount it on the roof of a ATV or a truck or whatever, and you have it upward facing. And so the photos aren't taking images of the ground, because you're not interested in that. Exactly. You're interested in the quality of the power lines and the transformers and everything else. So in our system, the system is literally pointed at or focused, as we say, on the subject you want to collect data on. And that's another differentiator for us, is that any money you spend is on the subject you're interested on. You're not just collecting data everywhere in the direction. So if you're doing bridge inspection, you're going underneath the bridge, you have it pointing up, the cameras are looking at the underside of the bridge, not the asphalt on it.
Yeah, but it's such a creative way to come at the problem, is to stare at the exactly how are you using and what do you want to use the data for, and then building a literally a shoebox that can collect all of this data. We're talking about an extraordinary amount of data, though. I think you mentioned the laser itself is millions of data points per second. Where does all the data go? Because I'm imagining your shoebox starts to get a little heavy with all the content in it.
The electrons are very light.
They're light.
Yeah.
Yeah.
But no, good question. So we designed it for that purpose, that it could be out all day collecting data. So in our device, we have several terabytes, up to 5 terabytes, and we expect to expand that, of storage on the device. And all the data is stored on the device. But as I mentioned, you have a tablet or a computer that you control the device with, or you can connect it to later, and you download all that data to your computer and you upload it to the cloud. And we have other options available from a technology standpoint to do direct uploads and so forth. But you kind of want to store the data on the device first and download it later, so that you're not worried about internet connection and Wi-Fi or cellular coverage, and that you're not interrupting your mission to collect data with trying to manage data. Manage the data after the fact, and you upload that data to the cloud. But you're right, our device, as it is right now, if all 3 cameras are on, and say they're collecting at 10 frames per second, and the LIDAR is fully, you got all the beams on for the LIDAR, you're collecting a little over 1 gig of data per minute.
Whoa.
So it's quite a bit. Yeah, I just we were just in the US for a major rail line, and we just collected data for 1 hour on the rail line, and we collected 74 gigabytes of data in 1 hour. So
yeah, it's an extraordinary amount of information. Processing all of that information probably underscores another dimension hidden behind all of this, which is the need for the capability that can access this data and process it at scale. Because collecting the data is, it's just the starting point. Unless you interpret it correctly and do something with it, then the data itself is not that useful to you. How do companies now, armed with all of this information, how do they process it? Does it plug into, say, existing point cloud data set interpretation engines, or is there something beyond that they need to embrace? Yeah,
there's really 2 components to it. You're absolutely right. Processing is actually the hard part. With a couple of $1 million in a year or so of time with good engineers, now you could do integration like we did and build a basic mapping system. But the hard part is processing all that data and processing it accurately and relative to the components that you integrated in the mapping system. So that's really Lux Modus' specialty. We have a very advanced Amazon-based cloud processing environment called Lux Cloud, where you upload our data to the cloud. And this is us breaking down one of those barriers to entry again. Normally, in traditional mobile mapping, you have a desktop environment or you have a cloud environment with very expensive software, and you need a technician to process all of this data. All of our data is processed automatically. So you don't need to be trained in LIDAR processing, anything like that, to develop, colorized, registered photos in a colorized point cloud that's registered and so forth. You upload the data to the cloud, and our cloud environment automatically scales up or scales down depending on how much data you're uploading. So you could upload 5 scans or 500 scans, and it would only take a few minutes to process all of that data, spin up the number of servers required to process that data, and our data processes it all automatically. And then we have, so out of that, you get the colorized, registered point cloud, polarized point cloud, and all the photos. And we have another environment called Lux Web, which is actually where you do all your data management and your uploads and downloads and so forth. But that's where you get to view all the data, clean it up, denoise it, and we have a bunch of tools and functionality in there. But our output is our standard, industry standard LIDAR point clouds and image formats. So you could then put it into some engineering software or CAD or GIS or something like that, and then do feature extraction or 3D modeling. We also offer those services. We're a vertically integrated company, so we can do the full gamut of power line modeling and building envelope modeling and so forth. But most of our partners and most of our customers are survey companies or asset owners, and they already have those capabilities, but they need inexpensive point clouds collected at scale, and that's the major part of our business. But the really hard part, as I mentioned, processing that data instantaneously. You could go out in the morning, collect data, and in the afternoon, all of that data is available. Like for the example, for that rail collection, I went in the morning and collected that data and uploaded it, and as it's uploaded, it's available. So that afternoon, everyone that was involved in that project can look at all the data.
Yeah, the turnaround time we're talking about here is shrunk dramatically. So everything's shrinking when you think about it. You're except the amount of data you're collecting, which is a bit of a paradox. Yes. You're actually expanding dramatically the amount of data and the ease with which you can collect that data. I mean, a shoebox mounted on a quad, for instance, or a bicycle. And yet the ability to process the data is shrinking in addition because you're taking advantage of the cloud processing abilities to crunch through that data at scale. So this is fundamentally altering how engineers must think about the world of physical as-built information data sets. I'm imagining. I'm assuming that's one of the things that they sort of react to when they see the power of this at scale.
Absolutely, it's been interesting to watch, and it's still occurring. The new engineers and younger people, millennials and so forth, that are getting into more management positions, they get it, of course, a lot better than those of us that have been indoctrinated to long periods of time. But you're right, it's a fundamental switch. In the past, it's been, okay, we have to send surveyors out. It costs X amount of money. It takes X amount of time. It's an analog process. It's only linearly scalable. If I want twice as much survey done, I need either twice as much time or twice as many surveyors, hopefully. And then it takes X amount of time to get that in. Now it's the complete opposite. It's really inexpensive, but we can do it really fast. So whether we collect, you book, our equipment for 1 day. So whether you collect for 1 hour or 8 hours, it doesn't really matter. It's basically the same cost. So you can actually go and collect all of this data, tons and tons of data. You might not use 99% of it, but you can afford to collect that much data because it's so inexpensive. That's the complete opposite of the other one, where you really have to watch your costs for survey and data collection. We have unlimited amount of data available to you, and just delete the stuff you don't use, or collect extra data, and maybe you'll use it someday and you can call it back up and use it if you have to. So it's a complete paradigm shift in that regard. So from an engineering standpoint, and from just even as building, let alone operations and maintenance, you're asking or informing people, the customers in the market, that they can change their business model. Just say, go and collect tons of data. Don't be so worried, cost and schedule sensitive about data collection. Cost and schedule sensitive about what you're going to do with the data. And you have a lot of experience with digital twins, Geoffrey, and I'm sure that's one of the things that you're seeing. The paradigm to switch to a digital twin, as opposed to just managing the asset, to life cycle of a digital twin and all the data that goes with it. The data is not the issue anymore. We can get data. It's what do you do with the data? And that's we were inhibited from being able to do that.
Yeah, I mean, the number of use cases come to mind. And right away, my mind already immediately goes to using this capability to collect physical real world point clouds of the real world, using that data to create my own metaverse or my own software version of my real world. Now, in the oil and gas world, the energy world, we call that a digital twin. But it's largely the original engineering diagrams, and maybe a computer has kind of faked up or simulated an asset. What we're now talking about is you can actually create a virtual real world right down to the rivet. This is what your asset looks like. Is this, how do you see this unfolding? Do you see engineering companies and operators embracing this quickly, or is this going to take some time for the industry to get their head around this? Because as you point out, we're breaking some norms here about data and accessibility, cost, and the like.
Yeah, it's interesting, and it really, from our experience, it depends on what market vertical you're in. There are some markets, like on the government side, for asset management, asset inventory, like scanning the roads, hey, how many linear meters of guardrail have to be repaired this year, kind of thing, right? They're quite open to it. They see the value of it, particularly from the safety component, that you stay in the vehicle and you drive up and down the road, as opposed to having surveyors get out and walk along the side of the road for measurements. I think governments are adopting it way quicker because there's a clear cost benefit and a safety component. To more complicated assets like a pipeline or a major piece of rail infrastructure, they're slower to adopt it because they have more ingrained business practices that are based on the traditional way of doing it. So we're not asking them just to change their view of data. You're inherently switching from analog processes to digital processes, not just figuratively, but literally. That has disruption throughout a vertically company. So it's if you're making a model of a plant, or like the pipeline corridor, for example, to do environmental monitoring after you have the digital twin of construction, and then you're constantly regularly scanning it or surveilling it through time to look for ground disturbances or encroachment and things like that. That's doing that digitally at the desktop is, from a business standpoint, like think of our major pipeline operators here in Calgary. They're used to sending people in a truck to drive up and down the right.
Oh yeah.
Right, and they have a business designed around it. We're saying you don't have to do that.
Yeah, it's fascinating. I live in British Columbia, and there's power line corridors here go up and up, literally up and down mountains to supply various communities in British Columbia with electricity. And I take my mountain bike on these roads because they're kind of fun as a mountain biker. Bloody dangerous if you're in a white pickup truck. So it's I can certainly see where power utility companies would kind of come to grips with this I would assume quite quickly. Now you mentioned a handful of use cases already. So one was pipelines and recording pipe as built infrastructure before it goes into the ground, literally. Canopy and vegetation detection. Guardrail detection, curb modeling so that you can figure out where to say put your latest set of charge points for your new electric vehicle rollout. What are some other use cases, creative use cases companies have come to say this has saved us in some fashion?
Well, there's really, it's interesting. It kind of falls into two categories. There are organizations that might be a private company or like an actual company, publicly traded or not, but a company or an agency that owns an asset. In either case, they might own an asset that's really old. So you might have a pipeline that's really old, a rail line that's really old, and they basically don't have any data. So they want to do their baseline as built or asset collection or start a digital twin. For example, me going down in the States recently and doing that scan is for a rail organization, that literally has rail lines and elevated structures and platforms that go back to the 1800s. That they don't have very accurate information for. So it's even starting with that use case of just starting an as-built or starting a digital twin. So and throughout North America, particularly in Europe, there's a lot of infrastructure where there's a banker's box full of drawings, and that's their as-built or that's their digital twin. So there's a lot of organizations out there just starting. So that covers every market vertical. Then the other part of the spectrum is just companies that are building brand new infrastructure, and they know we can go digital instantly, and we don't have to have a mix of manually collected data or they're beginning to learn what they're like legal, for example. Your legal survey, your legal cadastre has to be manually collected. Surveyors have to go out and manually legally survey property, absolutely, crossings, all that kind of stuff, right? But other components that don't need millimeter accuracy, that only need centimeter accuracy, just go out and scan it, drive up and down, pay a summer student, go up and down. So it's really those two camps. It's people who have really old stuff and people who are building new stuff. But it does span every market vertical. Even like in Australia, we've got, a municipality looking at just monitoring property. What's the value of individual houses? Are their fences too high? When they used to send out city inspectors to go, oh, that person didn't get a permit to build that fence that high, things like that, right? Or what assessing, again, property value, some build an extension on their house, replacing manual processes with just being able to do it at the desktop. So pretty much the sky's the limit in terms of what you can do 3D modeling for, now that you can do it at scale and inexpensively.
Yeah, scale, fast, and inexpensively. Where's the energy industry? This is a show about energy innovation. The energy industry is very concerned about environmental performance. Is there an ESG angle here, an environmental social governance angle? I imagine there's a savings in not having to, say, fly an aircraft and get grainy photos of the ground. So there's a safety aspect. There's perhaps like some carbon savings there. What do companies tell you the impact this is on say their environmental performance?
Well, it's interesting because that's really where we started with our company. We started in the pipeline side. Myself and the other co-founders already had existing pipeline customers from our other businesses. And you're right that, I actually think the ESG component to our business is the largest potential, or is where we're going to have the largest potential on the energy industry. It's one thing to change the way surveyors are doing collecting data in the field and make the survey work easier and safer and maybe less expensive and collecting more data. But because we're going straight to digital and the type of data we collect is detailed 3D models that you can spin around and literally look at centimeter by centimeter of a pipeline during construction and monitor its health or the health of the right-of-way through time, that is something the society hasn't had before. So one of our biggest customers one of the major pipeline companies. And one of the biggest values they see, one of the drivers for them using us is, as building the pipeline during construction, but they're able to go to the First Nations and say, see, this is how we're building the pipeline. This is how we did this river crossing. Here is irrefutable 3D data, photos of every centimeter of that pipe, that open cut, or here are the trees we've cut down, but we've replaced them. Here is the right of way through time, that no geotechnical disturbance, as opposed to going into a First Nations community or to the government, the regulator, and just giving them a drawing, 2D drawing on a printout, or having a fancy website. You can actually show them a 3D model that is irrefutable, right? And where you're, especially in a congested right of way where you're crossing other pipelines, you're shooting the gap underneath them, you can go and prove, no, here's a 3D model of us, our pipe going underneath your pipe. At this time, this was the weather conditions, this was the substrate, you can see it in the photo. It's an unbelievable amount of data that's inexpensive and easy to collect. So I think that's actually the biggest impact on the energy side. We even see it on the upstream side. One of the things we're beginning to market now is just transactions and assurance for upstream assets.
Yeah.
So you're right. So companies go and buy and sell thousands of wells at a time based on reservoir and so forth. And the story, often they buy things, they're like, oh, well, this well site actually doesn't have an access road in, or it's in disrepair, or that tank battery is falling apart kind of thing. You can now just literally drive in to a site, drive out, in 30 seconds, you can produce a highly detailed 3D model of a well site or a facility, literally in seconds with detailed photos. So you can do quality assurance on assets you're buying or selling, or proving a cleanup or a reclamation to the government. You can say, here's all the data from this well site you reclaimed, right?
Yeah.
It's very inexpensive. Instead of sending somebody to the field, taking pictures with their iPhone and writing down a bunch of notes, you just drive around and drive out, and it's collected.
Yeah, it's going to be a huge for the industry in so many dimensions. Joseph, thank you very much for coming on Energy Innovations today. If people want to learn more about Lux Modus and what it's doing, where do they go? What's your website?
Our website is luxmodus.com, which is luxmodus.com. We'll also be at the International Pipeline Conference coming up in September here in Calgary. And on our website too, of course, you can find other contact information to reach out to us. So thank you very much, Jeff, for the opportunity to come on and tell our story. And it was really great to see you again.
Yes, same here. Let's not let 20 years go by before we do
That's
it
right.
again next time.
That's right. Absolutely. Thank you, Jeff.
You bet. This has been another episode of Energy Innovations. And by all means, press the like button, leave a comment, or share this with your network. And others will get advantage of this useful insight and development in energy innovations. I'll return shortly with another episode. Bye for now.
Thanks for joining our latest interview on Energy Innovations from EnergyNow Media. Don't forget to hit that like button, subscribe, and share this video. You can contact us at info@energynow.com to book your appearance or to become a sponsor.